Welcome to day 2 of Parallel Lines. Parallel Lines Part 2 and Proving Parallel Lines. First, let's review day 1 a little bit. So we have GF is parallel to HJ. So when I have parallel lines, I first am going to star box, alternating from the top corner, and I go around in a circle, star box, and I repeat the same thing on the next set of angles. Star, box, star, box. This tells us which ones are the same and which ones are supplementary. So the next thing I do is I'm going to try to determine my relationship, meaning do I have 2 stars that are equal to each other, 2 boxes that are equal to each other, or one of each that are supplementary. So here, if I look at what I've got, I have x plus 80, and that's a box, and 6x minus 100, which is also a box, which means I'm going to use box equals box. I can replace my boxes with my angle measures. The first box, x plus 80. The second box, 6x minus 100. Next, I'm going to solve this in Desmos. So I'm going to bring up Desmos. And in the first box here, I'm going to type out my equation. X plus 80 equals 6x minus 100. And I don't see my answer line here, so I'm going to zoom out a little bit until I see a line. Zoom out again. And I see it there on the edge. I'm going to zoom out one more time. I click on it and it says 36, 0. So x equals 36 is my answer. Now, if I go back and read the question, it does say solve for x, so I don't have to do anything further. 36 is the one that I'm going to choose for my answer choice. Here we have find the measure of angle DYZ. So I see the markings that they're parallel, which means I'm going to start out by star boxing. Star, box, star, box, and I repeat on the bottom set of angles. Star, box, star, box. Sometimes you have to get a little creative about your positioning of your stars and boxes. You don't want to cover up the angle measure. So you notice this box is a little bit above the angle, but it's so that I don't have to write on top of my angle measure and lose some of that information there. So next up, we got to figure out what we have, determine the relationship. I have a star in 5x plus 10, and here 4x minus 19 is a box. So because I have 1 star and 1 box, then those are going to be supplementary. Star plus box equals 180. I can write out my star value, which is 5x plus 10, plus 4x minus 19 is my box value, equals 180. So this is the expression I'm going to put into Desmos. I'm going to write my full equation in box 1. Alright, so I don't see my line just yet. I'm going to zoom out until I do. There it is. I'm going to click on the x-intercept. So my x value there, 21, is going to be my value of x. So x equals 21. But if I go back and read the question, it does say find the measure of angle DYZ. So I'm going to go from D to Y, from Y to Z, and that's what I'm looking for. So I'm looking for this box right here, which is 4x minus 19. So the measure of angle DYZ is 4x minus 19. I can plug in my answer for x into the box right here. And then I'm going to type it into Desmos to get my answer. So in that second box in Desmos, 4, instead of x, I'm going to put 21 in parentheses, minus 19, and that gives me back 65, which is my answer for angle DYZ. Alright, a little more review from day 1. In this figure, line B intersects parallel lines E and W. So parallel lines, I'm going to star, box, box, star, box. And I repeat for my second set of angles. Star, box, star, box. Now, my question asks which pair of angles is supplementary. So which ones add to 180? And that means it has to be a star and a box, because star equals star, box equals box. But when we add up a star and a box, we get 180. So I'm going to look 1 and 2. Angle 1 is a box. Angle 2 is a star. That is one of each. That looks like my answer. If I check the others, 6 and 3 are both boxes. 5 and 7 are both stars. 4 and 2 are both stars. So, answer choice A was right. That's the one I pick. So, how do we prove that two lines are parallel? So, if we're going to prove two lines are parallel, we have to satisfy two conditions. Our first condition must be that you have to have one angle on each parallel line. If we had two angles on one line, we're not really talking about the other one at all. So we do have to have one angle on each line. So I want one on P and one on H here. Then the second part is the statement has to be true. That's kind of a no-brainer. If the statement is not true, it doesn't prove anything. So let's try this one. We are going to star box first. Star, box, star, box. Repeat on the other set of angles. Star, box, star, box. Alright, so which statement would prove that lines P and H are parallel? So what I'm going to do is I'm going to make a little table. And the more you practice, the less you'll have to do this. But I do recommend drawing it out at first. So we make our table for condition 1 and condition 2. We're going to draw a line underneath and then down in between. So I'm just going to put a Y for a yes and an N for no to make it easy. So if I look at angle 1 is on line P. Angle 2 is also on line P. So it does not satisfy the first condition of one angle on each line. This expression here tells me nothing about line H and those angles involved there. So that is a no. And because I have a no, I can go on to the next one. So 2 and 5. Angle 2 is on line P. Angle 5 is on line H. Sorry, this should say H instead of Q. So when we have one on each line, though, our condition is true. So it does meet condition number 1. Let's look at the second condition here. Is 2 and 5 congruent? Is it true? So 2 is a box, 5 is a star. It is not congruent, so I move on to the next one. The measure of angle 3 plus the measure of angle 8 equals 180. 3 is on line P. 8 is on line H. And again, I apologize, I wrote Q on my notes. But they are on separate lines, so that is a yes for the first part. Now we need to see if it's true. 3 is a star. 8 is a box. And a box, this says star plus box equals 180. So it is a true statement, so we found our answer. Now, if we were to keep going and check our last answer choice, we would find they are on separate lines, but it is not true. A star and a box are not the same. Let's try number 2. Which angles must be supplementary to prove that P is parallel to H? So, to prove it, it has to be one on each line. And it has to be supplementary. So instead of true, we want supplementary. So the supplementary part of those angles has to be true. So I draw out my little table. Condition 1, condition 2. And I first look at condition 1. So 2 is on line P, 6 is on line H, so they are on separate lines. Are they supplementary? 2 is a box, 6 is a box. They are not supplementary, so condition 2 is not met. 1 and 2, well, 1 is on line P and Q is on line P, so condition 1 is not met. We don't know anything about line H. Move on to our next one, 3 and 5. 3 is on line P, 5 is on line H, so condition 1 is met. However, 3 is a star and 5 is a star, and to be supplementary we need one of each, so condition 2 is not met. Last one, 4 and 7. 4 is on line P, 7 is on line H, so they are on separate lines. Angle 4 is a box, and 7 is a star. And so 1 box, 1 star, that means they are supplementary, so our condition 2 is proven here as well. So we are going to circle D for our answer. Alright, I want you guys to try this one. So we need to prove that L and M are parallel. So you want to prove that, you want to go ahead and make sure you have one angle on each line. And then you want to make sure the statement is true. Try that and hit play when you're ready to check your answer. Alright, let's check our work here. The first thing we need to do is star box. And we star box our angles. Then we want to prove that condition 1 and condition 2 are both true, or both met. So if I look at 1 and 2, they are both on line M, so that is a no. We move on, 2 and 3, both on line M, that's also a no for condition 1. We have to have one on each line. 4 and 5, we have one on each line. And it also has to be true, so we want to see, is 4 congruent to angle 5? 4 is a star, 5 is a star, they are congruent, that is true. So that is our answer. Quickly, let's look at one more together. Using the diagram above, what condition would not prove that A is parallel to B? So, first thing I'm going to look for is to see which one is not true. So we want the opposite. We want either on the same line or not true. So I need to star box. And when I star box, I'm going to look 1 and 3 are not on the same line. So we do want to have 2 either on the same line or not true. So in order for 1 is congruent to 3 to be our answer, then condition 2 would not have to be met. But if we look, 1 is a star and 3 is a star. So they are the same, and it is true. If we go ahead and look at B, 1 and 6 are on separate lines. So condition 1 is met. I'm going to go ahead, let's just check and see. If they're not on the if they are on the same line, then we know that we found our answer. So let's go ahead and try this for the others. Kind of a little bit of a shortcut here. But that's usually the first thing that I will check. And then I'll go back and see what's true. So, angle 1 and angle 5 are on separate lines. So condition 1 is true. 3 and 4, though, you notice, are both on line B. So they are on separate lines. And we found our answer. All right, so let's go ahead and do some guided practice together before we work on our independent work today.